In this video, we are going to be going over section 5.4, which is all about the greatest common factor and the least common multiple. But before we get into the nitty-gritty of the greatest common factor and least common multiple, let's talk about it and get a little bit of an introduction. So in Module 2, when we found common denominators to add and subtract fractions, we were unknowingly finding something called the least common multiple. In the last section, 5.3, we learned how to find factors and multiples of a number. And in this lesson, we're going to take all of that knowledge and learn more about the least common multiple and greatest common factor. So the least common multiple is the smallest multiple of two or more numbers that have, oh my goodness, sorry. The least common multiple is the smallest multiple two or more numbers have in common. So in the last section, we were just finding multiples of just one number. But in this section, we're going to find the smallest multiple of a group of numbers. And then our greatest common factor is the greatest factor that divides evenly into two or more numbers. So before, we were finding the factors of one number, and in this section, we're going to find the greatest factor, or the largest factor, that a set of numbers, or more than one number, can divide evenly into. And then just a quick note before we get through some problems. In this lesson, the least common multiple will be abbreviated as LCM, and the greatest common factor will be labeled as GCF. So as we've seen here, this means least common multiple and greatest common factor. And then we will also learn two different methods to find a least common multiple and greatest common factor. So let's first work through these couple examples, and we're going to use this first method, or method 1. And this first method is good to use in order to understand what the least common multiple and greatest common factor actually means. So with that being said, let's work through it. Let's first find the least common multiple of 16 and 24. And to do that, let's start off by listing the multiples of 16. And remember, multiples are the counts of whatever number we have. So in this case, let's count up by 16. So we have 16. 16 plus 16 is 32. 32 plus 16 is 48. And let's go up by one more multiple. 48 plus 16 is 64. Now let's do the same thing. Find some multiples of 24. So let's start off by 24. 24 plus 24 is 48. And then we can keep going from there if we need. But for now, let's stop here and see if we can find any multiples that match up. So we have 16, 32, 48, and 64. We have 24 and 48. One thing you might notice is that we have 48 and 48 here. And in this case, because these are our first two multiples of 16 and 24, that is going to be our least common multiple. So our least common multiple is 48. So that's our answer for this one. And then our greatest common factor of 16 and 24 are as follows. So instead of finding each multiples individually, here we're going to find the factors of each number individually. So 16, the factors of 16 is 1, 2, 4, and 8. And then the factors of 24 are as follows. 1, 2, 3, 4, 6, 8, and 12. Now, we have one thing you will notice is we have some factors in common. We have a 1 in common, a 2 in common, a 4 in common, and an 8 in common. But one thing to keep in mind is that we're looking for the greatest factor that divides evenly. In this case, the largest factor that divides evenly both in 16 and 24 is going to be 8. That is the largest factor that both these numbers have in common. So let me circle that here. So our greatest common factor is going to be 8. Now looking at example 2, I encourage you to pause the video and try it on your own. And assuming you have worked through it together, let's work through it together. So we have our least common multiple. So we're going to start off by listing off the multiples of each number. So the multiples of 15 are going to be 15, 30, 45, and 60. And then looking at I apologize. I was supposed to take out this example. So let's ignore this here and move on to the next example. So if you want, you can try this in your own, this problem, but I will say that it gets to be a lot using this first method that we just did here. So that's why we are going to be introduced to a second method. So the second method essentially is a shortcut to method 1, but it's important to understand, it's important to use method 1 so that way you can understand. This gives us like a visual of what the greatest common factor and least common multiple even means, or what it is. So with that being said, let's learn this shortcut method. To do this, we're going to start off by listing the numbers that we're given. So we're given 57, 33, and 45. And what we're going to do is we're going to draw this like L shape around this. And then we have to think about a number that divides evenly into all three of these numbers. So first things first, these numbers are not all even, so we can't divide all of them by 2. But since they're all odd, what we can do is see if we can divide them all by 3. So we're going to write out a 3 here. And then we're going to divide all these numbers by 3. And 57 divided by 3 divides evenly. You'll get 19. 33 divided by 3 is 11. And 45 divided by 3 is 15. Now once you get here, you have to think, do any of these numbers have a common factor that we can pull out like we did here that divide evenly to every number? In this case, we don't have any common factor that we can pull out again out of all three of these numbers. So we're going to stop this part here, and we're now going to actually begin to find the least common multiple and the greatest common factor. So let's first start off by finding the least common multiple. And to find least common multiple using this method, we're going to take the number that we got, the numbers that we get out on the side, and we're going to multiply it, all those numbers, and we're going to multiply the numbers that we get on the side by all the numbers on the bottom as well. So to find the least common multiple, we're going to take 3 times 19 times 11 times 15. And if you multiply all those numbers together, you will get 9,405. So that's our least common multiple. Now, as you can see, imagine writing out all the multiples of all three of these numbers until we get to 9,405 for all three of them and realize that, oh, hey, this is the least common multiple. That would be a lot of work to do to list out all the multiples individually, which is why method 1 really is only useful to understanding what we're actually doing with this method. Now, our greatest common factor is just the product of all the numbers on the side. In this case, we just have a 3 pulled out, so our greatest common factor is just 3 in this case. Now, looking at example 2, we have 80, 72, and 120. Now, because all three of these numbers are even, I'm going to start by dividing each number by 2. And I'm going to pull out a factor of 2. So 80 divided by 2 is 40. 72 divided by 2 is 36. 120 divided by 2 is 60. And all three of these numbers are still even. So I'm going to divide all of them by 2, or take out a factor of 2 again. 40 divided by 2 is 20. 36 divided by 2 is 18. 60 divided by 2 is 30. And again, we have all three even numbers, so I'm going to divide by 2 again. 2 divided by 20 is 10. 18 divided by 2 is 9. 30 divided by 2 is 15. And now we're kind of stuck. We can't take out a common factor or divide a number by all three of these numbers evenly. So we are done with this part of this problem. So let's now find the least common multiple and the greatest common factor. I encourage you to pause the video and try to find the least common multiple and greatest common factor now that we have this ladder drawn out, I guess you could call it. And assuming you have tried finding these on your own, let's work through it. So to find our least common multiple, remember we're going to multiply all the numbers on the outside. So we're going to do 2 times 2 times 2 times 10 times 9 times 5. So if you multiply all these numbers together, you should get 10,800. Yay! And then for our greatest common factor, we are going to take the product of all the numbers on the side. So our greatest common factor is just going to be 2 times 2 times 2. And 2 times 2 times 2 is 8. Now, let's talk about a new concept. So you are now at the point you are now prepared enough and have enough skills to begin to be talking about the idea of variables in math. And variables are letters. And one thing I will say is please don't let letters or variables in math scare you. I promise they're not as bad as you think they are. So let's work through this together and we will get through this. And I promise you, you'll be better than you think you will be. So please don't get scared. Don't give up. let's just work through this together. We got this, okay? So before we work through these problems, let's talk about a couple rules first. So we're gonna need a couple rules to find, so I'm sorry, I'm all over the place. So what I want to say is here, we're going to be finding the least common multiple, the greatest common factor of some variables here. In order to do that, we need a couple rules. So we need this thing called quotient rule, which is when we divide two things with an exponent. And when we divide two things with an exponent, all you have to do is take the two exponents and subtract them from each other. So we take the exponent that's in the top, and then we subtract that exponent in the top by the exponent in the bottom. And then when we have two numbers that are being multiplied together, or two variables that are being multiplied together that have an exponent, we're going to take those two, and then we're going to add the exponents together. So I know that's kind of confusing, but it'll make sense once we work through these. So let's first start off by doing this ladder. So we're going to write out an x and an x squared. And now we have to think, is there something that this x and this x squared have in common that we can pull out? And in this case, we can pull out an x from these two because these both have an x in common. So if we think about it, what is x squared? What might that be? Well, we know something squared means this thing multiplied by itself 2 times. So x squared is just x times x. So we can pull out an x from these two. So to find out what x divided by x is, let's write that out. So x divided by x. Actually, let me write this here actually. So x divided by x, and then x squared divided by x. So what I'm doing here is I'm essentially doing the same exact process I was doing here when I would say like 2 divided by 80 is 40. We're doing the same thing here. It's just with letters. So x divided by x, these two actually just cancel out, and then you'll be left with 1. And x squared divided by x, well, as we see here, we have two things being divided. So we're going to use this quotient rule here. So x squared, so we have x squared, and then this x here basically has an exponent of 1. So we have x squared minus 1. X squared minus 1, or we have 2 minus 1, it's just 1. So we're just left with x. So now we're done here. So let's write out our least common multiple and greatest common factor. So our least common multiple, as we've seen above, is when we multiply all of the numbers on the outside. So I apologize for this work here, but I was just showing you the between work. So we're just going to take this x, multiply it by 1, multiply it by x. So our least common multiple is going to be x times 1 times x. And anything times 1 is just itself, so we just have x times x. And remember, when x is alone, they basically have an exponent of 1. So we're going to use this rule here to combine these exponents because they are the same variables. So we have x and x. So in other words, we have x 2 raised to the power of 1 plus 1. And 1 plus 1 is 2. So we have x squared for our least common multiple. For our greatest common factor, remember that is whatever we pull out to the side. And in this case, we just have an x pulled out to the side and nothing else, so we don't need to multiply anything. So our greatest common factor is x. working through example 2, we have x squared and x to the 4th. Now, I encourage you to pause the video and give this a try. Just give it your best shot. And then now let's work through it together. So here, we have an x squared and x to the 4th, right? So we have to think about what can we pull out of these two. And it might be helpful to think about it in this way. So we have x squared, which as we've seen above is just x times x. We also have x to the 4th. Which x to the 4th is just x times x times x times x. Because x multiplied by itself four times is just x to the 4th. So what can we pull out? What's the greatest number of x's we can pull out from these two numbers, x squared and x to the 4th? If you're thinking we can pull out 2 x's from each, you are correct. And we know that if we multiply x times itself 2 times, we get x squared. So I'm just going to write out x squared here. So now we're going to have to find out what we get when we divide these variables. So x squared divided by x squared, this just cancels out. We're left with 1. So we're going to put a 1 here. And then x to the 4th divided by x squared, that's going to be x to the 4th minus 2. And 4 minus 2 is x squared. So I put the x squared. So now let's find our least common multiple and greatest common factor. So our least common multiple is going to be the product of all the numbers on the outside. So we're going to have x squared times 1 times x squared. So anything times 1 is just itself, so we're just going to leave that out. And we're going to have x squared times x squared. And as we've seen from above, when we have two numbers, or 2 letters, or 2 variables that are the same, and they're being multiplied together, and they have exponents, we can just add the 2, so we get x squared plus 2, or x raised to the power of 2 plus 2, and that's just x to the 4th. There's a lot of steps here, but once we work through them, they're not too bad. So now, to find our greatest common factor, we find what we pulled out to the side, which is just x squared. So our greatest common factor is going to be x squared. Now, working through this example, we have 3x squared and 6x cubed. So let's write this out, 3x squared and 6x cubed. So to break this down step by step, let's think about just these numbers that we have out in front. We have a 3 and a 6. So just ignoring these variables here, let's just do what we did above with the numbers. So we have a 3 and a 6. What can we pull out of a 3 and a 6? If you're thinking we can pull out a 3, you are correct. So 3 divided by 3 is just 1. And then we have x squared. And then 3 divided by 6 is 2. And then we have an x cubed. Now, let's worry about the variables like we did above. So what can we pull out of x squared and x cubed? If you're thinking we can pull out an x squared, you are correct. So now let's work through this. So we have an x squared, so it's x squared divided by x squared. Remember, we have x squared divided by x squared. Those just cancel out. We're just left with 1. So we have 1 times 1, and 1 times 1 is just 1. And then we have this 2x cubed here. So we have to think about what is 2x cubed divided by x squared. Well, this 2 we can kind of just ignore for now because we basically have this x squared. If it helps you, we can multiply it. You can think of it as being multiplied by 1. So 2 divided by 1 is just 2. And then we have this x cubed and x squared. So we're going to, remember, take the exponents and subtract it. So we have 2 and 3 minus 2 is just 1. So we have 2x to the first power, or in other words, just 2x. So we have 2x here. And we can't pull anything else out of these two bottom variables and numbers here. So this is it. This is our simplified ladder here. So let's find our least common multiple by multiplying everything that we have on the outside. So we have a 3 times x squared times 1 times a 2x. So now to multiply all this together, we're going to multiply everything that has an x together and multiply everything that are just numbers together. So I'm going to write this out in parentheses to group this stuff together, to organize this. So we have a 3 and a 1, and then we're going to multiply this x squared and this 2x together. So when we do that, we get a 3 times 1, which is 3. And then remember, when we multiply variables together with exponents, we're going to add them. So you get times 2, and then we get x squared plus 1. So 2 plus 1 is 3, and 3 times 2 is 6. So we're going to get 6 times x cubed. That's our final answer for our least common multiple. And then we have our greatest common factor, which that is the product of the things on the outside, or I should say the product of the things on the side here, which is a 3, and then times x squared. And this is just 3x squared. And that's our answer. And then this is our last example. So I know this is a lot, but working through it, taking time to work through it, it'll begin to make sense. This is a lot at once, I will admit that. But it'll begin to make sense once you work through it more. So looking at our very, very last example, I encourage you to try it on your own. And now, assuming you have tried this, let's work through it. So we have a 10, x to the 5th. We have a 15, x to the 8th. And then we have another 15, but it's being multiplied by x to the 4th. So let's first think about what numbers we can pull out of 10, 15, and 15. If you're thinking we can pull out a 5, you are correct. And then from here, if you note, you might notice I left a space here. And that is because next, I'm going to think about what we can factor out of x to the 5th, x to the 8th, and x to the 4th. And the largest thing we can factor out of these three variables, x to the 5th, x to the 8th, and x to the 4th, is x to the 4th. Now, one thing, if you haven't noticed yet, when doing these problems, I'll write this here. You always factor the lowest exponent, or I should say not lowest, the smallest exponent from the variable letter portion of the, I'll say latter. Yeah, okay. So when I say latter, by the way, here, that is very messy. So when I say ladder, by the way, I just mean this because it kind of looks like a ladder. So given this, we always factor out the smallest exponent from the, I should say not variables or letters. So we always factor out the smallest exponent from the variables, part, not portion. From the variable, sorry, I'm going to say variable letter parts of the letter. So here, these variable parts, if you noticed, we actually factored out an x to the fourth, and our smallest exponent we have is x to the fourth. So if you need that rule, you can always use that as your falling pad, as a safety pad if you don't know where to go with the variables until it starts to click in your head, because it does take a little bit to understand. So let's work through this last part. So we're gonna first start off by dividing all the numbers. So 10 divided by 5 is 2. And x to the fifth, I'm going to work through this on the side. So x to the fifth divided by x to the fourth, that is x to the 5 minus 4, which is x to the first, which is just x. So we have 2x. And then 15 divided by 5 is 3. And then x to the 8th, x to the 8th divided by x to the 4th, that is 8 minus 4, which is 4. So here we're left with 3x to the 4th. And then 15 divided by 5 is 3. And then we're going to divide x to the 4th divided by x to the 4th, which just cancels. So we're just left with 5. Now from here, we can't divide out any more numbers that have a common factor. And because this 5 has no more variable, or doesn't have a variable anymore, we can't pull out any more variables. So this is our simplified letter. So from here, let's find our least common multiple and greatest common factor. So remember, our least common multiple is the product, or when we multiply everything on the outside. So we have 5x to the 4th times 2x times 3x to the 4th times 5. So to do this, actually I'm going to erase this GCF here. To do this, let's put all the numbers inside a parentheses. We have 5 times 2 times 3 times 5. And if you're like, whoa, Mason, where did you get all these numbers from? I got them from here. So I'm just grouping the numbers, and I'm going to group the variables together. So we have this 5, which is here. We're going to multiply this by 2, multiply it by 3, multiply it by 5. I'm just showing you visually how to multiply numbers and variables when we got a mixture of them. So we have this. Now let's multiply our variables. We have x to the 4th right here and here. And then we're going to multiply that. We're going to multiply an x times x. And then we're going to multiply an x to the 4th. And this 5 doesn't have a variable, so we're going to close that parenthesis off. So 5 times 2 times 3 times 5 that is going to be 90. And then here, remember when you multiply things together, we add them together. So you get 4 plus 1 plus 1. 4 plus 1 plus 1. Here, let me write this out. We have x to the 4 plus 1 plus 1. So your final answer should be 90, x to the 9th, because there's nothing more we can multiply together. So that is your least common multiple. And last but not least, greatest common factor. Now remember, the greatest common factor is whatever we have on the outside, or on the side here. And since we only have one thing on the side, that is simply just going to be our greatest common factor. And congratulations, you made it through the video. And I hope you the best of luck and good luck. And I'll see you in the next video.